welcome to SND College of Engineering, Yevla. In today's lecture, we will discuss the topic Harmonic Analysis. The Fourier series expansion for the periodic function of period 2 pi y is equal to f of x is equal to a0 by 2 plus summation n runs from 1 to infinity an cos nx plus bn sin nx. If the function which is to be analyzed into harmonic is not given by the formula, that is the function which is not given is in terms of the explicit form, but it is given in the set of discrete number in the tabular form, in such a case we cannot evaluate the integrals, but we can determine the value of few terms of the Fourier expansion by method of approximate integration. The terms in the Fourier series expansion a1 cos x plus b1 sin x is called a first harmonic. The second terms a2 cos 2x plus b2 sin 2x is called second harmonic. The term a3 cos 3x plus b3 sin 3x is called a third harmonic, and so let xi yi where I runs from 0 to m minus 1 with the set of given values where xi are equispace, that is the difference between the each values of x is equal. So let f of x y is equal to f of x be a periodic function of period 2 pi defined in the range 0 to 2 pi, and xi which is to the value of xi which is x0 plus 2 pi I divided by m, that is each sub interval is of length 2 pi upon m. The coefficient a0, an, bn where n runs from 1, 2, 3 and so on in the Fourier series can be determined by using the formula a0 is equal to 2 into 1 upon m summation I runs from 0 to m minus 1 yi. That is the formula to find the value of a0, which is 2 into mean value of yi. We take the summation of yi and divide the summation by number of values of yi. So we get the mean value of yi. Similarly, the formula for the an, which is an is equal to 2 into 1 upon m summation I runs from 0 to m minus 1 yi into cos nx. That is an is equal to 2 into mean value of yi cos nx. Similarly, next the Fourier coefficient, which is bn, which is to be calculated by using the formula 2 into 1 upon m summation I runs from 0 to m minus 1 yi into sin nx. That is bn is to be calculated 2 into mean value of yi into sin nx. See some important remark to this topic. The interval 0, 2 pi is divided into 6 sub-intervals of size 2 pi upon 6. That is, if we want to divide the interval 0 to 2 pi into 6 sub-interval, so for that 2 pi divided by 6 is equal to pi by 3, that is 60 degree. That is the difference between the each values of xi is to be 60 degree. So that is for the arbitrary function that is the arbitrary interval 0 to 2L. The value of x are to be given in the range 0 to 2L. Then the Fourier series expansion for this arbitrary interval, which is f of x is equal to a0 by 2 plus summation n runs from 1 to infinity an into cos n pi x divided by L plus bn sin n pi x divided by L. The value of a0, which is to be calculated by using the formula 2 into mean value of yi, that is the 2 into 1 upon m, the number of values. Here we take the n number of values, so 2 into 1 upon m summation y. Similarly, the formula is to be defined for an, which is equal to 2 into mean value of yi into cos n pi x upon m, that is 2 into 1 upon m summation yi cos n pi x upon m. The similar formula, that is for the Fourier coefficient Bn, which is equal to 2 into mean value of yi into sin n pi x divided by. So in this way, we determine the Fourier coefficient by using these given formulas for the harmonic analysis. So we find the first harmonic, second harmonic, and so on. So thank you.